So let's begin. My name is Anton, and we have Yossi together with me.
Hi all.
We are working on the Azure Monitor team. So our team is responsible for building products that use to monitor your application and infrastructure. Just raise your hand if you heard about Application Insights. Okay, everybody, cool. And have you heard about log analytics? Okay, we need to work on this. Okay. So Azure Monitoring Analytics is about three main things. First of all is visibility. So you have your application data. Okay, so I will keep it here. So you have your application data, you have your infrastructure data. Azure Monitoring Analytics enables you to collect your data from your applications whenever they're running on cloud or on-prem, and collect the data for your infrastructure, VMs, etc., that are running also on-prem or on Microsoft Cloud or on any other cloud. And you get all this data into one place, and then you can get alerts, notification, and dashboards like the ones that you see in this screenshot, all in one place. Second thing is about insights. So once you gain the visibility, you want to have advanced capabilities in order to diagnose problems in your service, in order to troubleshoot, to get to root cause analysis faster. And this is a part of the session that we are going to talk about more, is how we leverage machine learning in order to provide you, developers, service owners, insights about your service faster and in a more easy way. And the third value that comes from the first two is actually your ability to improve your services. So you run your services, you want to improve your performance, your availability, and with the visibility that you get and the advanced diagnostic tools that the Azure Monitor provides you, you can make your service much better and much better performing. So what are the smart insights in Azure Monitor? The smart insights are spread across three offerings. First one is in application insights. You have smart detections. Basically, what we take the domain knowledge that we have about the telemetry that is collected to application insights, like performance of your request, like page load times, failures, exceptions, and we analyze this data automatically in order to detect degradation problems, abnormal performances, etc. We also use smart clustering to help improve the diagnostic of your service. The second place where we apply machine learning in Azure Monitor is Azure Alerts. And with new capabilities, it's now available in limited public preview, which is dynamic threshold alerts. Basically, what we do, we take the historical data of the metric, we learn it in order to produce the threshold automatically without you configuring or setting the threshold by yourself. And the third place is in diagnostics. So Azure Monitoring gives you a really strong log analytics tool called Log Analytics with a really rich query language that you can query all your log data and application events data. And here we provide you inside the query language tools to do time series analysis, identify anomalies in your data, identify trends, and also perform clustering and a pattern comparison on the data that you collect to log analytics. So this is a short recap of the capabilities, and now we will switch to the demos. Just a second. OK. So the first demo, this is a screen that you probably know well. This is the Application Insights overview blade. For those of you who are less familiar with Application Insights is a Microsoft application performance monitoring product, which provides via its SDK collection of telemetry data to Application Insights, where you can analyze server performance, page load times, requests, and failures. It has a lot of great capabilities that I'm not going to cover now, but you can go to our session tomorrow about application monitoring log analytics, like application map, which maps all the dependencies of your service, which request goes to which service, smart detection, which I'm going to talk about, live stream metrics, actual ability to log in real time to the server and get the visibility in latency of seconds about what's going on the service, and much more. So, smart detections. So when we talk to our customers, one of the things that we hear from them is actually not always knowing about what alert to configure or what data to monitor. And we took this gap and developed in our in-application insights about 13 detectors which detect different performance problems in the application. Here we see an example of 3, and I will just go deep dive on each one of them. So first one is an abnormal rise in failure rate. So all of us monitoring who monitors our services, from time to time we have degradation in our service. One of the indications of degradation in service is increase in failure rate. And what application does behind the scenes, by leveraging machine learning, we actually learn the baseline for the normal failure rate for the application. And in case we identify that increase in this failure rate, like you can see in this example, that it's gone from 0.8% failure rate to 22%, then we issue a notification, like the one that you see here. And in addition to notification, so once you get an alert, you have questions like, what is the impact? How many customers are impacted? What regions are impacted? And first, to know if this is an important issue. Second, to understand from where do you start the diagnostics. What we do in Application Insight, we apply smart clustering on the failures that that created the spike, like those that you see here, and basically provide you an analysis. In this case, it was easy. We see 99% of the failures coming from specific request name, from a specific cloud role instance, and coming from a single country. Making this very easy for me to identify if this is the problem that I want to investigate now, and if I want to investigate, I understand where the problem starts. And another scenario that is also very important for me as a service owner is identifying new exceptions. Why new exceptions are interesting? All services have failures and exceptions. But there is a very high correlation between change in the number of the exceptions. And this is exactly what this detector does. It analyzes all exception types and will issue an automatic notification if a specific type has more exceptions than we learned in the previous, like versus its baseline. So here, the exception type is actually SQL data, SQL client, SQL exception. And what we see here is that looking on the previous week, this exception did not occur before 1 day before and on the day of the detection. And you can also see here the distribution that prior to those 2 days, 100% of the exceptions were from some other type. Those exceptions were not appearing at all. And on those 2 days, those exceptions were very high from the overall exception volume. So to summarize this section, in Smart Application Insights leverages our domain knowledge because we understand the schema of the telemetry that is being sent. So we know to identify exceptions, we know to identify failures, we know how to identify performance problems, and we create automatic detectors which notifies you as the developer about the problems in your service without any specific setting from your side. Now I will switch to Yossi, who will talk a bit about dynamic threshold alerts.
Okay, so we need to switch the microphone. Just a minute. Yeah, we need to switch the microphones.
No.
I'm on. Okay, hi all. So I'm going to present today the new dynamic threshold capabilities that we are now adding to Azure Alerts. Okay, so let's assume I'm a service engineer in the Contoso service. The Contoso service is hosted on Azure VMs. And recently, our engineers discovered a correlation between high service loads and customer experiencing issues with the service. So let's see how Azure Alerting can be used in order to create an alert and help them identifying issues with their service. So I'm going to go to the Azure Alerts. Just a minute. Not working. Okay. I'm going to Azure Monitoring, creating an alert without the mouse. Okay, create a new alert. I'm going to choose the target using my subscription. Just a minute, let it go. Let's try again. I'm going to choose the subscription for my service. Not working. So interesting how it doesn't work in the demo,
Yeah.
as you can expect.
Get on the Wi-Fi.
Just a minute. Wi-Fi is okay. No Wi-Fi. Something is disconnected. 50 Wi-Fi. Oh, okay, great.
Okay.
So going back to Azure Monitoring, I'm going to configure the alert. Let's hope it's going to work this time. Yeah, great. So creating a new alert, selecting the target. This is the easy part. No. Okay, great. So choosing my subscription. Baseline service. And choosing the virtual machine. And choosing my VM. So once I'm done with the VM, let's add a criteria to the alert. I'm going to use the percentage CPU for this alert to detect the high load issues. As you can see here, my service is actually works once an hour, does the batch processing, and then going idle. So I'm going to try to use the regular static alert threshold. If I'm going to use, let's say, 60% for this alert, I'm going to be alerted on high spikes, but I'm going to miss the scenarios where my service stops working and the CPU goes idle. So obviously, I can't also use a low threshold, then I'm going to get a lot of alerts, and this is not what I want. So I'm going to try to use the new dynamic threshold capabilities that we now add to the Azure Alerts. What you can see here is that the system queried for historical data and construct a baseline. A baseline is actually introducing two new time series for the metric itself, the high threshold and the low threshold, which present the expected metric behavior. Once the metric behavior is started outside the threshold, we consider it a deviation from the baseline and issue an alert. You can see here that the high threshold and the low threshold nicely identifies here the spikes in the CPU when the service actually does the work. And once the service goes idle, you see the threshold adjust to be lower than the high values. So a few words about the algorithm behind the scenes. Our algorithm actually has two phases. The first phase is about automatically seasonality detection that we use in order to detect the seasonal parts of the signal. We can identify daily, hourly, and weekly seasonality parts. And once we detect the seasonality parts, we construct it outside of the signal itself. and move over and leave only the residual part of the metric. Then we go over to the second part of the algorithm, running only on the residual parts of the metric, which actually is in-house cultivated algorithms that work on the residual parts and can build the expected behavior, what we call the baseline. So you can see here the result of the algorithm. Then we can continue configuring the alerts. I can choose the condition type to be greater than, which will alert me once the metric values are above the high threshold. This typically is useful for scenarios of high performance. I can also choose the lower to alert me on the lower threshold. This will alert once the metric value are less than the low threshold, and it's typically for a drop in transactions or when my service stops working for some reason. I can also control the alert sensitivity to be high and get more alerts, or to be low and get less alerts, and continue configuring the alerts. I can control the bin size of the metric and the frequency of the alert, and I can also control this ignore data before, which in this configuration I can exclude data from the training period. If for some reason my service experienced some issues and I would like to exclude this data from the algorithm, then the baseline, then I can use this option and skip this subnormal data. Now, once I'm done with configuring the alert, I can continue and enter the alert name and description. I'm not going to do it now, and define an action group. Azure Monitoring now allows you to create an action group which can then be used in order to configure different alerts. And once the alert is triggered, the action will take place. The action types, as you can see, which are now supported, the email, the SMS, Azure Function, and etc. So this is it from the dynamic threshold alerts. And it's now open for limited public preview. You can join the preview and use it yourself. Thank you. Anton will continue.
Yeah. So thank you, Yossi. So as Yossi said, this capability is now open. Okay, is now open for limited public preview. So you can go to aka.ms/dynamic threshold and sign up. And it's actually available, so you can set it up on every metric that's available in Azure Alerts. So Azure Alerts collect metrics from your infrastructure, all your Azure resources, and more and more resources are now being supported here. Now we switch to our third demo. And this is actually an example of how you can leverage machine learning constructs in log analytics query language. So not many of you raised your hands when I said if you know about log analytics. So let me just spend 1 minute telling you about what is log analytics. So basically, when you collect in data to application insights or to Azure log analytics, all this data becomes available for querying in this interface. This is like a SQL-like query language, which enables you to run very, very fast queries on all your telemetry. It can be terabytes of data, and still will get really great performances. And in this example, I will show you how we are using the linear regression operator that is available inside the query language in order to help us with root cause analysis. So basically, the problems that we have in this service that we actually try to investigate. Sorry, wrong query. Just a second. Yeah. So basically, the problems that we have in this service is that we have exceptions coming from multiple application versions. In many services, you have global deployments and various application versions running simultaneously. So here I constructed a query which is looking on exceptions that are collected from all my resources and all my deployments, and I grouped them by application version. So here I can see a time series of exception count for each application version. And this is, here is the list of the application versions. We can see that we have, at this period that I'm analyzing, 21 live versions. And for me to understand if I have an issue in this time, I want to narrow down the investigation only to application versions that had a change in exception rate. So what we will do now is we will apply a linear line fit in order to project okay, which of those 21 time series had the most significant change over the period of time. So I'm using this operator here, series fit line, which will run linear regression on every line, on every time series that is available, and will return me the slope of each one. So as you can see, first of all, the result came very fast. And what I see here in the result for each application version, I see it is a line slope, meaning the change. So here I immediately identify the top 2 application versions that had the most significant change. And now instead of going out and investigating 21 application versions, I can only focus my investigation on those 2 that had the most significant change. One of the great things with log analytics is that we have really a lot of examples for people who want to start trying it out. And basically, when you go in log analytics and hitting on this control, you will actually see this is the demo portal, which you can access. And when you hit on this control, you can see all the queries that are available. And many of them are available for smart insight scenarios. So here come a few examples: how to analyze failures, how to perform how to identify degradation using time series parameters, etc. All of them available in the link that I will show in the next slide. So to recap what we have so far. In Azure Monitoring, in Application Insights and Log Analytics, we are using the power of machine learning together with our domain knowledge in order to provide the best tools for your developers to monitor your application, to detect problems in your application using smart detections, to set smarter threshold with the dynamic thresholds in Azure Alerts. And as I mentioned before, it's a limited public preview, so it's available, but you still need to sign up. So you just can go to AKMS Dynamic Threshold, and there you get all the documentation about what Yossi presented, and also we'll have a link to how to sign up to the public preview. And of course, we have in-query machine learning in log analytics, which enables, for the more advanced scenarios, you have all the data available in Azure Log Analytics, and now you can leverage the machine learning constructs available there on time series analysis and clustering in order to do the advanced diagnostics on your service by your own. During build, we have 2 more sessions. One is a breakout session tomorrow by our Director of Program Manager, Shiva, who will present how to DevOps using Application Insights and Azure Log Analytics, and where you can learn about the best opportunities that you have to gain visibility to your application in infrastructure monitoring. You have a workshop, I think it's scheduled on Wednesday. And we have booths in the tools area where you're welcome to come and ask questions about log analytics, application insights, machine learning in Azure Monitoring, etc. We'll appreciate if you could rate our session. And Yosin, if we have some additional time, we will be happy to answer any question you have.
Thank you.
OK. Thank you very much.